Hi dear students, this is Wajid Shah and welcome you back for the video session of the topic magnetic flux, which is given on page number 115. Magnetic induction tells us how close together magnetic field lines are, as it tells us the strength of the magnetic field. Now we define another quantity of magnetic flux, which is the dot product of the magnetic induction B and vector area A. Magnetic flux is defined as the number of the magnetic lines of the forces through unit area A. We can write magnetic flux, that is B dot delta A. Like electric flux, magnetic field is also having some lines of the forces. Similarly, like electric flux, we have a concept of magnetic flux. That is, the concept of the strength of magnetic field. As you can see from the equation that this is a dot product of magnetic field B and area A. Flux is a scalar quantity, so we can write it like a dot product, and we can also write it like B delta A cos of theta, where theta is the angle between magnetic field B and area A. Phi represents the magnetic lines passing through the vector area A placed perpendicular to the field. Direction of the vector area element is normal to the surface area A when we have angle equal to 90. So, this is magnetic flux. The unit of magnetic flux is Weber, after the name of a scientist. Weber. This is the SI unit of magnetic flux. We can write 1 Weber, WB is the symbol, is equal to 1 Newton meter per ampere. 1 Weber is equal to 1 Newton meter per ampere. This is magnetic flux. From this equation 1, we can also generate a new concept of magnetic flux density, like B is equal to flux divided by A. Flux density, flux per unit area. So magnetic induction, magnetic field strength are another term which is called magnetic flux density, another term used for B. So we can also define the topic of magnetic flux density from this equation, like 1 Tesla is equal to 1 Weber per meter square. Tesla is the unit of magnetic field strength, magnetic flux density, or magnetic induction. Weber is the unit of flux, meter square is the unit of area. So, explaining into the diagrams, with the help of diagrams, we can also explain magnetic flux. This is a very similar concept to electric flux. Like, for example, we have a unit area like this. The direction of area is horizontal. Let us we say magnetic field lines are passing through this area horizontally, like this. The angle between them is 0. So we can say that the total flux of this total unit area, that is B A cos of 0. We can say B into A. Maximum flux in this case when the angle is 0. We can also explain we have a horizontal plane and the direction of area is vertical towards upward, and a magnetic field is passing nearby this plane. The direction of area is perpendicular to direction of the magnetic field, that is angle 90. We can have flux is equal to B A cos of 90 or 0 flux. It means that no number of lines is passing through this unit area. However, they are passing very close to the area but not passing through the area. The third type is a type like when magnetic lines of the forces are horizontal and the area is placed with an angle theta other than 0 or 90. So we can have a general equation for the flux is BA cos of theta. So this is the concept of magnetic flux. If you still have any question, any problem, any doubt in your minds, you can ask your teacher through WhatsApp group or individually, personally, or on Facebook. Thank you. Have a nice day.